All right, so we're going to take a look at solving an equation using substitution. We've already used the word substitution when looking at chapter 7 because that's how you check your answer. You're substituting values for x and y back into the equation. And so that's exactly what this is going to look like, is replacing, substituting for a variable. So let's take a look at what that's going to look like today. All right, so a system of equations, this is just kind of a review, which is kind of nice because we just took about a week break from it. So a system of equations is two equations in two variables. That's what we're going to focus on in Algebra 1. Algebra 2, we do take a look at some three-variable systems, but for right now, we're going to define it as two equations in two variables. Where is the solution found? When we look at the graph, the solution of the system of equations is found where the graphs of the two lines can intersect. Good job. That's what we're looking for. And so we need to keep in mind that our solution is always written as an ordered pair, which was pretty easy to remember, pretty easy to keep in mind when you were graphing because you had the coordinate plane there. What we're going to do now is start using algebraic methods. And so we're going to go through and solve an equation similar to what we did in the warm-up. And so we're going to get an answer of x equals 5. Well, remember, you need to have an ordered pair so that you have to make sure you solve two equations. One that's going to give you x equals and one that's going to give you y equals so that you can remember to go back and write it as an ordered pair. So if you can always remember that your final answer has to be that ordered pair, you're not going to forget to find the second number. And then keep in mind, regardless of which method we use, we can always check our solutions by plugging the ordered pair into both equations and checking for a true statement, okay? If your solution, if what you're telling me is the answer, makes either of the equations false, that means you're wrong, and you need to go back and start looking for your mistakes. So, let's take a look at what our steps have to be. So the steps for solving with substitution. So step number 1, you need to isolate one of the variables. And what that simply means is that you're going to solve for x or solve for y. Now you guys are pretty good at solving for y. We've done that quite a bit. We did that every time we graph. It's the same process when you solve for x. Isolate and then do the addition or subtraction and divide. The difference with substitution is I don't always have to solve for x or solve for y. I can solve for x now that I'm not graphing. Step number 2, substitute the expression. When you solve for x or when you solve for y, you're going to have some sort of an expression. Just like when we graph, we have y equals 2x plus 3. You're going to have this expression 2x plus 3. If you solve for x, you may have something like x equals 3 minus 4y. You're going to have this expression 3 minus 4y. And you're going to plug that expression from step 1 into the other equation. At this point, ladies and gentlemen, once you do that substitution, you should only have one type of variable. You should only have x or y. We're not going to have two variables anymore. Step number 3, simply solve this new equation for its variable. I don't know whether you're going to be solving for x or for y, but you're going to have one variable, and you're going to solve for that. And in fact, in some of your worksheets, we're going to start seeing t's and s's in the problems, or m's and n's. So you're just solving for whatever variable you have. And then what we're going to do, and I do have a screen with all this on there, guys, so if I get a little ahead of you, you will get a chance to catch up. You're then going to plug that answer into either one of the equations and solve for the other variable. So I'm going to get x equals 2. Rah, rah, I'm halfway there. I now have to substitute that x into one of our original equations and solve for y. So at that point, I'll have an x and a y. I'll have two solutions that I can write as an ordered pair. And then last but not least, you're going to check that answer in both equations. All right? So if we take a look, this is what your final step should look like, guys. So anything you need to go back and plug in. Alright, so ladies and gentlemen, let's go split screen and let's take a look at how we use these steps to solve a system. So let's take a look at what we have. We have the system of equations, x equals 3y plus 5, and 3x plus 2y equals 4. This is our first problem that we're going to solve. So step number 1 says to isolate one of the variables. So to solve for x or for y. So when you look at this system, do I need to worry about step 1, or has that already been done for us? When it says to solve for x or y, what that means is I should have one equation that starts with either, oh, my board's a little off, guys, sorry. That starts with either x equals or y equals. Do I have an equation that starts with x equals or y equals? Yeah, so step number 1 isn't always going to have to be done. Sometimes they give you a system where it has one of your variables already isolated. So that means I'm ready to go to step 2. I'm going to take the expression from step 1. I'm going to take this 3y plus 5, and I'm going to plug it in for x. Okay? It looks like I'm going to need to calibrate my board, guys. So if you can give me just a moment, I'm sorry about that. I thought it was working okay this morning. Alright, so we're plugging that in we're substituting that in for x. So that means I'm going to have the 3 still there. The only thing I'm replacing is the x. I'm going to substitute it in, and when we substitute it, we should substitute with parentheses around our expression. With putting parentheses around that expression, it allows me to be ready to recognize any distributing that I may need to do. I then need to include the rest of the equation, because remember, the only thing we're trying to get rid of is x, and substitute 3y plus 5 in its place. So I'm still going to have plus 2y, and I'm still going to have equals 4. Notice our little reminder here was, I know I've done my substitution the right way if I only have one type of variable, which means I have all x or all y in the equation. Is that what I have here at this point? Do I have all y's? Yes. As long as you're still going to have probably 2 variables, but they need to be the same type. So now I can go through and solve this. Well, this is back in September, ladies and gentlemen. Devin, what's going to be my first step? Multiply 3 by 3y and get 9y? 3 by 5. I still have plus 2y equals 4. Nate, what would I do next? So I have 11y, and then I've got this plus 15 equals 4. Sarah, what would I do next? Subtract the 15. So I have 11y equals negative 11. And Jaya, what would be my last step? Y equals negative 1. Do we agree with my algebra so far? All right, so that's step number 3. You're solving for that variable, y equals negative 1. It says then to take that answer and plug it into either one of your equations. I like using the top one, guys, and here's why. I need to find what x equals, and so this will give me x equals. The other thing I like to do to help keep myself on track, I plug this equation into the second equation. Now I need to plug this in to the first equation. So each equation should get substituted into at one time each, okay? The first one's getting substituted in as an expression. The second time you do substitution, you're going to the other equation and substituting in a value. The nice thing here is that there's no solving. You're just simplifying. You're simplifying that right-hand side. So I'm doing 3 times negative 1 is negative 3, plus 5 is 2. Our answers are going to be written as an ordered pair. So Taylor, how would I take these two answers and write them as an ordered pair? 2, negative 1. Beautiful. Now it did say that we can check our answers by substituting, by plugging those into the original equations. So I want you guys to get your calculators out. You'll have to read directions closely on your assignment tonight, because I'm not sure if it says to show your checks or not. But remember, when you're doing your checks, we're looking to see, can I plug 2 in for x and negative 1 in for y and make a true statement? So I'm going to take 3 times negative 1, that y value, and add 5, and I get 2. Can you guys see my calculator with the light on there? It's a little bit better. So I know it's going to work in that first equation because that's the equation that I originally plugged y into. What I really need to check is this second equation, because I haven't plugged x or y into that second equation. So I need to go and do 3 times x, which is 2, and then I need to do plus 2 times negative 1. I need to do that check and make sure it works there. I get 4. That's what it said it should equal, so I have 4 is equaling 4. So what do I know about this ordered pair? It's a true statement. It's a solution. All right. So that's what your checks will look like, ladies and gentlemen. I did glance at the worksheet. It says then check your answers, so I want to see you plugging those into each equation. But it's something as simple as 3 times 2 plus 2 times negative 1. You just have to show me equals 4. Okay? Let's take a look at the next example. All right, so how are we going to do this example here? We have 6x minus 6y equals negative 14, and x minus y equals negative 7/3. Do we have x equals or y equals right now? No. So I need to make x equals or y equals. I need to get one of those two. I want to find an equation that's easy to solve for. So when I look at this one, I'm going to have to do some dividing by 6, which isn't difficult, but I'd like to avoid fractions as much as possible. So when I look at that first equation, I'm going to have to do negative 14 divided by either 6 or negative 6, which is going to give me a fraction. If I look at this equation, both x and y have coefficients of 1 or negative 1, which are never going to create fractions for me. So if I've got 2 equations to pick from, ladies and gentlemen, to do my substitution with to isolate a variable, I want to pick the one that has x or y with a 1 coefficient. So when I look at this first equation, x minus y equals negative 7/3, I like that equation for my isolating. So I'm going to isolate x by adding y to each side. You don't always have to have x equals, guys. It just happens that we've got 2 examples in a row where you end up with x equals. So I'm going to have x is equal to negative 7/3 plus y. I have x by itself. I have an expression that I can substitute into the other equation. The other equation was 6x minus 6y equals negative 14. Now we do have fractions here, guys, but don't stress out about them yet. Keep working through it. I'm going to plug this in for x. So what is my equation going to look like when I do that? What's the first thing I should write down on my paper? Kenny?
6.
6. Then what should come next? Parentheses.
Negative 7/3 plus 1.
Beautiful. What would come after that, Michael?
Minus 6.
We have equals negative 14. I'm going to say Kendra, but I don't think I have the right name, do I? Is it Kendra? Help me out. Caitlin, that was choice number 3. Caitlin, do I have all the same variable here? Either all x or all y in the equation. Beautiful. I know I've substituted the right way. So now I need to go through and just solve it like a chapter 3 equation. Distribute 6. That should give me negative 14 plus 6y minus 6y equals negative 14. Do we agree, Will? Did I do my distributing right? Or are you just going to blindly trust me that 6 times negative 7/3 is 14?
Yeah.
Am I right, guys? Okay, thank you. So what do we do next?
Add 6y.
Add 6y and negative 6y. So what is 6y plus negative 6y? 0. It's gone. So you're left with negative 14 equals negative 14. You have no variable. Ladies and gentlemen, has that happened to us before in algebra? Yeah. Well, we've got 2 choices. We have either infinitely many solutions, or what would be our other option? No solutions. How am I going to pick between those two when I lose my variable? Yes, 50-50, and that's how we like to live life, baby. This is Vegas. No, it is math, and there's always a right answer. I can always get it right. So how do I decide? Well, my question to you is going to be this. Does negative 14 equal negative 14? That's a true statement, which means this is infinitely many solutions, because that's true. If it's a false statement, then I pick no solutions, just like back in chapter 3. The reason that everything canceled out here, ladies and gentlemen, is because they were the exact same equation. And remember, the exact same equation meant it had the same m and the same v value, so those were our infinitely many solutions. If you flip over to the back side, I believe there are a couple of on your own. I would like you to do A and C for me. Okay, guys? I want you guys to work on A and C. I'll give you guys some time to work.